Welcome to the Explainer. We're jumping right into something that is literally rewiring how artificial intelligence works today. We are talking about the Model Context Protocol, or MCP. If you've ever banged your head against the wall trying to get an AI agent to actually talk to your local database or your company's internal systems, you know exactly how painful that friction is. Well, today we're demystifying how MCP completely bridges that gap and makes those headache-inducing custom integrations a thing of the past. Let's get right into it. Here's our roadmap. We'll start with AI's data silo problem. Then we'll be introducing Model Context Protocol. After that, we'll dive into writing effective agent tools, debugging and troubleshooting MCPs for when things inevitably break, and wrap up with the future of AI agents. Okay, let's dive into this. Section 1, AI's data silo problem. So I gotta ask, is your incredibly smart AI fundamentally trapped? I mean, think about it. We've seen this massive mainstream adoption of AI recently, and we're pouring billions into making these models smarter, faster, and better at complex reasoning. But despite all that raw brain power, these models are essentially living in solitary confinement. They are totally cut off from your real, live, everyday data. Anthropic actually hit the nail on the head with this one. They noted that even the most sophisticated models are constrained by their isolation from data, trapped behind information silos and legacy systems. Right now, every single time you want your AI to talk to a new data source, you have to build a bespoke, custom integration from scratch. You want it to ping Slack? Custom integration. Need it to pull from your internal database? Another custom integration. Building a truly connected system that can actually scale is almost impossible with this kind of fragmented approach. So how do we actually fix this massive bottleneck? That brings us to Section 2, introducing Model Context Protocol. Instead of that messy, tangled web of one-off connectors, the Model Context Protocol steps in to replace fragmented integrations with a single universal protocol. It's basically a universal adapter for AI. It gives your AI systems a streamlined, incredibly reliable way to grab exactly the data they need right when they need it. So what is it technically? MCP is an open standard that lets developers build secure two-way connections between data sources and AI-powered tools. And the architecture here is elegantly simple. You've got two sides. You either expose your data through an MCP server, or you build an AI application, an MCP client, that connects to those servers. And that's the whole shebang. It completely wipes out the mechanical burden of maintaining a dozen different connectors. Now that we've got the architecture down, let's talk about actually building with it. Section 3, writing effective agent tools. To write tools that actually work well, we really need to wrap our heads around a major paradigm shift. Traditional software is deterministic. When you hit a weather API, it spits out the exact same formatted data every single time, right? But AI agents, they're fundamentally non-deterministic. If I ask an agent, hey, should I bring an umbrella today? It might decide to call a weather tool, sure. Or it might just answer from its general knowledge. Or it might even turn around and ask me clarifying questions first. We have to design our tools to handle this kind of fluid, unpredictable behavior. So the crucial point here is how you actually hand data back to the agent. A classic mistake is building a tool that just dumps your entire database into the AI's lap. Imagine returning a massive, unformatted list of literally every contact in your system. LLMs have limited context windows. If the agent has to slog through 10,000 contacts token by token, you're wasting its precious brain space. A way better approach? Good tool design means returning a filtered, paginated list. Let the agent search and skip directly to the stuff that actually matters.
The Anthropic Development Guide gives us some fantastic best practices for this. First off, consolidate related functionality. Don't make separate tools to list users, check calendars, and create events. Just roll that all into one tool, like Schedule Event. Next, use namespacing, like Asana_search, so the agent doesn't get its wires crossed if it has 5 different search tools available. Set smart defaults. And this one is absolutely huge. Return meaningful context. AI agents really struggle with cryptic, alphanumeric UUIDs. They are so much better at reasoning when you give them actual names or natural language identifiers to work with.
And keep this number in your head, 25,000. That's the default token limit Claude Code puts on tool responses. That constraint really drives home why you absolutely have to optimize your tools for token efficiency. If your tool is prone to returning massive payloads, you've got to implement truncation, or better yet, error handling that politely tells the agent, hey, that's too much data, can you refine your search, instead of just failing and crashing the run. Building these tools isn't a one-and-done deal. It's a loop. You want to follow this continuous development workflow. Start with a quick prototype, maybe wrap it in a local MCP server. Test it out yourself. Then create evaluation tasks. real-world prompts to really stress test the system. Run those tests. And here's my absolute favorite part. Use the agent itself to analyze the results. Just feed the transcripts back to the LLM and ask, hey, where did you get confused here? Then, iterate and improve.
Of course, in the real world, code rarely works perfectly on the first try. So let's talk about Section 4, debugging and troubleshooting MCPs.
Let's look at a real-world scenario using Microsoft's troubleshooting MCP server for the AL language. It is fascinating to compare this with a traditional debugger. With a normal debugger, you're doing all the manual work, right? Clicking through visual panels, expanding variable trees. But an MCP server gives an AI, like GitHub Copilot, direct programmatic access to your debug session. The AI can just look at the state of your application and figure things out entirely on its own.
When you hit a runtime error, Copilot can automatically trigger 4 specific diagnostic tools through the MCP server. It'll use get stack frames to see exactly how the execution reached the crash. It uses get variables to inspect the state at that exact moment. It calls get source code for context, and get this, it can even programmatically add a breakpoint to pause the code exactly where it needs to dig deeper. It's literally like having a senior developer sitting right next to you. Now, if you're querying this yourself by chatting with the AI, you really need to understand frame IDs. Frame 0 is your current execution point. Frame 1 is the method that called it. Frame 2 is the caller's caller, and so on. If you want Copilot to look at the right stuff, you have to be specific. Tell it, show me the variables at frame 1, so it analyzes the correct state in the call stack. Otherwise, it's just guessing.
Another absolute game changer for troubleshooting comes from platforms like Sentry. You can actually wrap your entire MCP server object inside a Sentry handler. What this does is give you totally transparent visibility into all those hidden interactions the LLM is having with your tools behind the scenes. You can track exactly how long a tool call takes, trace the performance all the way down to the database level, and even set up alerts if your tool usage suddenly drops to 0. It takes the mystery completely out of what the AI is doing.
All right, let's zoom out a bit and look at the big picture. Section 5, the future of AI agents.
Donji R. Prasanna, the CTO at Block, summarized the vibe perfectly. He said, open technologies like the Model Context Protocol are the bridges that connect AI to real-world applications, ensuring innovation is accessible, transparent, and rooted in collaboration. Open source isn't just a nice-to-have here. It's literally the foundation for building sustainable agentic systems. By making MCP an open standard, we're making sure anyone can build these bridges without getting trapped in proprietary walled gardens.
And you can already see the momentum. It's explosive. We've got local service support baked directly into the Claude desktop app right now. There's a rapidly growing open source repository of pre-built enterprise servers for things you use every day, like Google Drive, Slack, Postgres, and GitHub. And major dev platforms like Zed, Replit, and Codium are already integrating MCP to give their AI coding assistants a deep contextual understanding of your codebase. This ecosystem is maturing at lightning speed.
Which leaves us with one final thought. The massive, frustrating walls between your smartest AI models and your most valuable data have just been completely knocked down. The protocol is out there, it's open, the tools are ready, and the ecosystem is thriving. So I have to ask, what internal data are you going to connect to your very first MCP server? Thanks for joining me on this explainer, and I seriously cannot wait to see what you all build.